So as we know, since it's like a release, ChatGPT just attracted a lot of attentions from academia, from industry, and everybody is excited about, I mean, the possibility of ChatGPT like transforming the society and the as well as the technical community as well. And today, I'm not going to talk about ChatGPT from its like a foundation, from algorithm system. Mainly, I'm going to talk about from practical way, how ChatGPT will be helpful for our research, how ChatGPT will be helpful for our society, as well as like potential applications and the limitations of large language model. Okay, my name is Ben from Rice University. Unfortunately, it's not working. I may need this to be working. Okay. Yep, working. Okay, cool. Yeah, today's talk will be mainly categorized into 3 components, including the capability of ChatGPT and applications as well as limitations. Please note that here, although I use ChatGPT as a terminology, however, I mean, behind that, there are a lot of like different versions of large language models. That's why I will use this ChatGPT as a kind of a general notion of large language models as well. And especially there are many, I'm going to talk about a little bit about this later, but there are a lot of like closed source and open source versions of different types of large language models. What ChatGPT could do? Okay, so if not all of you, I believe most of us have tried ChatGPT before. And here I would like to show 2 quick examples. So for example, we will be able to ask ChatGPT to like write a programming code for us. And for example, we can say, can you show me an example of bubble sort? And the ChatGPT will return very nicely curated like examples. And also you can ask a large language model to say, help me write a short note to introduce myself. And in addition to that, a little bit different from traditional like language models, we will be able to interact with ChatGPT, such that you can ask, hey, how about give me a more a shorter version, a more brief version, an abstract version of the self-introduction. And these are like a basic usage of ChatGPT in our daily life. And actually, all of these kind of very nice interaction and very nice results are based on a technique called transformer. Attention is all you need, which was published in 2017. And after its release, although we have been aware of ChatGPT very recently, however, over the past 7 years, the whole technical community are just intensively investigating transformers for different purposes, not only for chatbot, but also for many different types of applications in natural language processing, computer vision, social networks, and so on. And the key point of transformer here is like a self-attention mechanism allows the transformer-based models to capture long-range dependencies much more effectively than traditional models, such as recurrent neural networks. And here, if you are not familiar with the technologies of transformer, that is fine. However, most of us, we are familiar with machine translation, right? Here, I would like to make use of an example from machine translation to show you how transformer really works. We have the input from a foreign language, and the transformer is to work like a black box, such that it will transform it to like English as an output. And inside the transformer, it is constructed as multiple encoders to like really understand, trying to understand this language. And we also have decoders trying to like kind of like map the original input into this output. And this is a basic, very high level mechanism how transformers really work. If you are interested in digging into more technical details, we don't have much time to really go through it like very carefully. And you can refer to this 2017 paper. However, because I was invited to just give so many talks about how large language model really works, that's why I have had a hard time to really try to explain transformer in an intuitive way. I asked the ChatGPT, what should I do? Okay, how to really explain transformer in an easy way, and it provides very nicely curated answers. And let me explain them like in a more detailed level about transformer. Okay. So we have encoder decoder architecture, and I can read the first bullet item for you. Okay. Think of the transformer model as a language translator in a United Nations summit. The encoder is responsible for understanding the input language, listening, and processing, while the decoder generates the translation in the desired output language. Okay, very nice explanation about how this kind of encoder decoder architecture really works. And then similar to this, it also explains like a self-attention mechanism, multi-head attention, positional encoding, layer normalization, feed-forward neural networks, residual connections, one by one, and very nicely using real-world examples in an intuitive way. And now, I mean, I was so impressed by the capability, how ChatGPT could really explain how it itself works and in an intuitive way, much better than a data science veteran. Okay, so this is very impressive. That's why you can see the capability of transformer. It can do a lot. Okay, I would like to also emphasize there are like very nice properties, technical properties of transformers. For example, it allows like a parallelization. Because of this self-attention mechanism, it allows like we will be able to process language as tokens instead of like we have to rely on the dependencies of languages like similar to previous deep neural networks, such as those in recurrent neural networks. Also, because of the residual connections, transformer-based models will be able to deal with the vanishing gradient problem very nicely. That's why the performance is very good. However, again, it's a very, I would say it needs a lot of comprehensive background knowledge. If you are interested in transformers, this is a foundation of this wave of large language models. Please refer to a lot of like, just a lot of online materials and tutorials. You can take a look. Next, you may have this question. Transformer was like invented in 2017, and since then on, just a lot of companies, they have released different versions of commercial and open source large language models. But why ChatGPT is doing so well? And what are the secrets behind the ChatGPT comparing to many other models? Is it magic, or it's like there are some like engineering and scientific like insights behind the ChatGPT? Here, I would like to introduce what are the engineering secrets which power the ChatGPT, at least to make it at this level of performance in this wave. Okay, here please note that most of the material, because like the technical details of ChatGPT are not fully revealed by OpenAI, although they claim they are very open, but actually it's not the truth. So that's why most of the technical contents I'm going to introduce today, they are based on the revealed documents by of InstructGPT, which is considered as a sibling model to ChatGPT. Okay. And to train an InstructGPT model, the core technique is called reinforcement learning with human feedback. And it can be roughly divided into 3 steps. The very first step is to collect human written demonstrations on prompts submitted to the API and train supervised learning baselines. And it works in this way. So firstly, a prompt is sampled from our whole prompt dataset. Prompt is like the way how you interact with a large language model. Here we show an example. Try to explain the moon landing to a 60-year-old. And this is an example of prompt for ChatGPT. And then a labeler demonstrates the desired output behavior. So here is the very first trick I would like to mention why ChatGPT is working on so well. Because like they somehow organize, collect, model, and integrate human feedback very nicely in terms of like providing response, the very nice response or desired response to this specifically sampled prompt, such that they will be able to learn a supervised learning model to fine-tune GPT-3 results. And this is the very first time, ChatGPT introduces human feedback into the process of training the model. The second step is to collect the comparison data and train a real-world model. The prompt and several model outputs are sampled. And specifically, what we want to do is like, okay, we will ask a human labeler to rank all of the outputs from best to worst. D, C, A, B. This is the ranking from human beings to rank the outputs. Which one is preferred out of like four outputted like results? And then the data will be used to train our real-world model. And remember, in the beginning we mentioned the trick behind the secret behind ChatGPT is called reinforcement learning with human feedback. And this is the second time how OpenAI is organizing, collecting, and model and integrate human feedback into the process of training ChatGPT, especially the reinforcement learning model as a real-world model. And the third step is to optimize this policy. Policy is a very specific terminology in reinforcement learning against the real-world model using this reinforcement learning architecture. And specifically, a new prompt will be sampled from this dataset, and the policy will generate an output. The real-world model trained from the second step will be used to calculate a real-world output for this like output from the last step. And the reward is used to update this policy using PPO, which is the algorithm in reinforcement learning. And as we can see from these three steps, so they very nicely employ human feedback and integrate and model this and integrate this into this whole process of training using a reinforcement learning architecture. And with all of this, I would say more like engineering efforts, we will be able to like push ChatGPT into the next level of success comparing to previously released large language models. And this is very nicely done, considering like how we can better engage human labelers, how we can really make use of human knowledge to be used in the process of training a machine learning model. And that's why, I mean, still there is a lot of like debate or controversial discussion among the community, saying like how much the technical contribution is from ChatGPT. But actually from my very personal and biased understanding, ChatGPT is so successful mainly because of how we can very well nicely organize human efforts, which is very important to push the last mile of success for many machine learning and AI models. After seeing like how ChatGPT is really constructed, I would like to, as we can see from the title, experimental investigation, right? That's why I'm going to show you a lot of like experimental results, and not only done by my group, but also, for example, this piece of results is from another research group. And the first set of results I would like to show is performance on a very traditional and classic natural language processing task called text summarization. Basically, what we want to do is like to input an article, and ideally we are able to have a very nice summary outputted by our machine learning model. And we compare ChatGPT zero-shot performance, meaning like we don't do anything for ChatGPT. We just use a vanilla version to get the results to see how it really works. And ChatGPT has never seen the data before, has no idea about what the data will be taken by the model. That's why it's called a zero-shot. We compare this with previously fine-tuned results on the summarization task. Fine-tuning results mean like the model has a basic understanding of what the data will be looking like. For example, here we compare with like 5 different types of data sets, ranging from very specific biomedical data sets such as COVID-ET, which is basically some literature about COVID, and also some of the data sets are like a general domain data set, news articles such as QM-SUM and QM-SUM Golden. And these are like collected from general domain for news articles. And we compare the two models over different types of standard metrics, such as 1 character overlap, R1, 2 character overlap, L character overlap, and they're like, and put everything together. And as we can see from this table, so some observations we will be able to make is like ChatGPT achieve comparable performance with traditional fine-tuning methods, such as as we can see, especially for general domain, it may outperform fine-tuning model in general data sets in the news domain. As we can see from QM-SUM and the QM-SUM golden data sets, ChatGPT actually, even without seeing the data before, okay, zero-shot performance, it achieves very competitive results. Unfortunately, it's not perfect, right? From the first data set, COVID-ET, ChatGPT is not working as well as a fine-tuning data set. It is believed that the reason behind this is still ChatGPT is an expert. It has seen just so many articles in the library. However, for some of them, for example, very vertical articles such as COVID-ET, such as biomedical literature, it may not necessarily be able to see them before. That's why, although it's a very smart people, it will just read so many literature, but it's not perfect. So for some a very constrained, specific data set, it still cannot perform very well. And these are the constraints. Another task I would like to mention here is called machine translation. And also we compare ChatGPT with other commercial systems, such as Google, DeepL, and the Tencent systems in terms of the translation task. For example, from Germany to English, Romanian to English, Chinese to English, and so on. And from this set of results, we will be able, and it is compared according to it's called a blue metric, which is a metric to say, okay, how much overlap between the outputted outcome comparing against the gold standard labeled by people. Okay, from this result, we can see ChatGPT is comparable to commercial systems in translation tasks with very rich corpus. For example, for the task with a lot of open and public resources, such as English to German, because it's not surprising, we will have a lot of articles related to English to German, right? That's why it performs very well, even for zero-shot performance. Okay, however, it performs poorly in tasks with less corpus. For example, from Romanian translated to Chinese, we don't expect to see a lot of this kind of corpus in public domain. That's why ChatGPT has no or little chance to see this kind of translation. That's why it performs very bad. Okay, and the conclusion we will be able to make from this standard evaluation will be, okay, ChatGPT is good in some general tasks, but it's not perfect. That's why we consider it's promising, but we do not necessarily need to worry about ChatGPT's performance against many commercial systems. We still prefer to use a Google Translation or Tencent Translation in our daily life, right? I thought this way, probably even a couple of weeks ago, from this set of very serious scientific evaluation. However, I had a very kind of eye-opening discussion with one of the leaders from this domain working on machine translation. So I have never worked on machine translation by myself. That's why I had a conversation with them after one of my United talks. What I learned, actually, I was a little bit shocked because what they told me is although from the standard evaluation, from this kind of very serious experiments, we can say, oh, from traditional NLP tasks, NLP metrics, ChatGPT is okay, but we don't need to worry about that too much. However, they have done intensive user studies internally. They have set up another metric in terms of user satisfaction, in terms of whether people are happy or unhappy about the translation results. And the ChatGPT is way better than traditional machine translation models, mainly because ChatGPT is so has done a lot of intensive efforts trying to make this outputted article very smoothly read by people. And they consider people in the loop of training this whole process. That's why it's not that surprising after learning the results. ChatGPT's outputted results will be much better than those commercial systems, which may or may not be very consistent and easy to read, right? Everybody has, most of us have been using machine translation systems before. And we can see there are some breaking sentences, there are some unreadable outcomes from the machine translation systems. However, they are working extremely hard to change their architecture from traditional ones to transformer-based models, hopefully to make this much more user-friendly and much more readable. Yes, please. Oh, yes, that's a very good question. Actually, most of the results are based on ChatGPT 3.5, GPT 3.5, yeah. And because we haven't had a chance to really test GPT-4.
4 is much better than 2.5.
Yes, that's right. That's right. Yeah. So this is a very good question. Actually, I told some of my friends. So previously, if I prepare one set of slides, I can use that for over a year, no problem. People are happy. But now it's like I have to update this every couple of weeks. Every time before I give a talk, I try to integrate some new contents I learned from archive, from social media, from different channels, try to integrate into my slides. Yeah.
Now you talk about the low source language like Romania to try English, right? But you can actually fit ChatGPT is a plugin on that anyway nowadays. So then the problem doesn't exist.
Yes, that's right. That's right. And again, the results are based on some previous evaluation, and actually this set of experiments is not done by my group even. We collected the best results in the market. We tried, yeah. And especially what I wanted to present here is the results from a scaled level, instead of I can surely test it within 5 minutes for some basic understanding, but these are not compiled results based on scaled experiments, yeah. And here are some conclusion or summary. We want to say what are the use cases and the non-use cases for ChatGPT. And they're very good at creative and complex tasks. For example, coding and creative writing. And also for some tasks with limited or no labels, fine-tuning a smaller model is typically very challenging or impossible to match GPT-3's 0 or 1 few shot performance. Also, it is very good at some knowledge-intensive tasks, such as those question answering, or in some of the applications. We really want our model to be able to mimic human beings, such as chatbot, because this wave of large language models, they just paid a lot of efforts, try to be user-friendly, try to mimic human beings. That's why chatbot is a very nice applications of these large language models as well. However, it's not perfect. We don't need a ChatGPT in all of our applications. And for example, in some of them, when we feel it's very expensive, or we have a lot of privacy concerns to make use of OpenAI ChatGPT API, at that moment we may not necessarily need to use ChatGPT, because we intensively work on biomedical applications, and later our fellow speaker Ray will also introduce some healthcare applications. Actually, when we work with the hospitals, they have a lot of concerns about privacy. They do not want their patient data to be scanned, to be potentially or possibly leaked to OpenAI. That's why, although ChatGPT shows a lot of very promising results, I mean, they just cannot tolerate any risk of leaking data to OpenAI. That's why these are no use cases. Also, similar applications are related to for example, financial domain and any domain with sensitive data sets. That's why many people are working extremely hard trying to push the open source large language models to be able to use by these entities. And also, some of the tasks, they have been there for decades. And eventually, over the years, we have collected enough number of label data. And we will have already established the local model. In this case, we may not necessarily need ChatGPT. And yeah, very recently, we have published an article about a summary of we curated a very nice decision tree about what kind of applications you are working on. Should you use large language model, or should you use locally refined model. And it was like released very recently and attracted a lot of attention. I will leave the reference at the end of this presentation. Okay, next I'm going to introduce some like applications, how we can better leverage ChatGPT, even though sometimes we are facing privacy concerns. And what I want to introduce today is like ChatGPT for clinical text mining very quickly, related to two tasks. One is called name entity recognition, and the other is relation extraction. These are two fundamental tasks which can be used to generate a so-called knowledge graph. Because basically what we want to understand is what are the nodes in a knowledge graph and what are the relations between between the nodes. And here we show an example. A 44-year-old man taking Paxlovid, experiencing like hives, troubling swallowing or breathing. And from this sentence, we will say some name entities. For example, the medication we are taking and the symptoms we are experiencing. And these are the name entities we try to identify. And also, our goal is to extract some relations between those entities. Because of some of the drugs, it costs some like, it is related at least. It is related to some symptoms. And okay, an intuitive way of using ChatGPT will be, hey, how about we ask ChatGPT to like identify those entities or relations? That's why my student, they have tried like a careful prompt engineering to say whether ChatGPT will be used to directly tackle the problem. And here we show like examples of using ChatGPT for NER task and relation extraction task as well. And unfortunately, we didn't get very good results. And also we have conducted some like very scalable experiments to have a better understanding of ChatGPT's performance on NER task and RE task on these two data sets, NCBI and GAD data sets respectively. And by comparing ChatGPT with another large language model on vertical domain, BioBERT, as we can see, ChatGPT does not, achieve the much worse results comparing to BioBERT on the NER task, such like 31st comparing to like 88. It's much worse, right? It's not even usable. And it achieved like a comparable, reasonable results in the relation extraction data set. Please note that ChatGPT here, it is a general model. It is not fine-tuned for a specific domain, but BioBERT, it is considered as a vertical expert on this specific biomedical domain. Okay.
So I thought ChatGPT also trained on some medical text, right?
Of course, yeah.
To pass the US medical exam, so I thought this.
Yes, so there's no doubt ChatGPT has paid a lot of efforts and has been exposed to some biomedical literature. That's for sure. However, my whole point here is like it's zero-shot performance, and it is not fine-tuned based on some specific data sets. Comparing to, I strongly believe, thinking about the size of the training data or the way how it is exposed to biomedical literature, it's not comparable to BioBERT or similar models. Yeah, that's my whole point. It's still considered as a general model. And that's why we were thinking, directly using ChatGPT is not that promising, and it's not like the performance is not comparable to like models such as BioBERT. Then what should we do? And we do not want our data in the hospital to be leaked to OpenAI. We just want to like leverage the capabilities of ChatGPT, but at the same time, we want to preserve our privacy. That's why what should we do? Here we just come up with a framework which can be roughly divided into 3 steps: prompt engineering in blue, data generation in yellow, and fine-tune the local model in red. As these 3 steps, the first step is like we try to perform some careful prompt engineering, such that we will be able to like help ChatGPT to generate some generate some very nice synthetic data, and which can be in combination with locally labeled data, which can be used to further train a model. And hopefully, this kind of generated synthetic data will be able to capture the main distribution of the data we are targeting, and it will be helpful for training a local model. And as we can see from this whole process, ChatGPT has never had access to our own local data, right? I mean, basically, we will communicate, interact with a large language model using prompts, and we do not need to tolerate the risk of like leaking our data, and we perfectly preserve our privacy. And at the same time, because of prompt engineering, we will be able to interact and communicate with ChatGPT such that we will be able to leverage its capabilities in helping us to train a better local model. That's a basic idea. And here we show an example of the prompt engineering we do. For example, we will ask ChatGPT to generate 3 positive examples followed by 3 negative examples for the gene disease relation extraction task. And very nicely, it will generate some like synthetic data. They are not true data. They are just fake data with some like possible label information. And we as human beings, we as like domain experts, we will be able to make use of prompt engineering to help ChatGPT to generate high quality synthetic data. And later, this kind of synthetic label data will be used in combining with locally manually labeled data sets to train our local model. And the performance is pretty good. As you can see, we achieved like 45% against the 31% original vanilla ChatGPT version, and significantly improved the vanilla version of ChatGPT in our local tasks, and while preserving our perfectly preserve our privacies. And the conclusion here is like we will be able to improve the vanilla ChatGPT by leveraging its capabilities as well. And at the same time, we don't need to worry about the privacy concerns, and which is very nice, especially for data sensitive domains. Okay, the last part of this talk, it's kind of like beyond the, I mean, it is related to the technical community. However, it is very much concerned by the society because of the too good performance of ChatGPT. Because many people worry about the misuse of large language models for this kind of very bad like applications. And people really worry about whether the use of ChatGPT will completely destroy our education system. And I can use a parallel example. I mean, another example. For example, when I was a little one, when I was a child, my father told me like, hey, son, so you need to really practice your handwriting very well. This is one of the main channels you communicate with people, right? Because at my father's age, I mean, the first impression everybody will be able to capture is to say, hey, this guy is very good at, writes very well in terms of handwriting. But now it's really another age. So in my office, it's really hard to find a pen even, right? That's like just after 20 years because of the use of computer technologies. That's another example. And here after 20 years, do our kids, do they really need to learn how to write an article? That's a big question to the society. And the people also at the same time, also worry about the use of ChatGPT. Will this like completely destroy our, destroy like the copyright of the articles, the copyright of our art work? And people really have a lot of concerns because of this. Many, not only schools, but also some countries, they ban the use of some institutions, companies, even some countries, they completely ban the use of ChatGPT. And then a question like raised to the technical community is like, if we will be able to identify machine-generated texts, then we will be able to somehow make sure this beast will be under our control, right? If we are able to really understand what articles, what texts are generated by machines, we will be able to not only good for our end users to better adopt ChatGPT in their daily life, but also very good for like system developers and researchers to be able to trace the generated texts and prevent unauthorized use, and also understand like protect our intellectual properties as well. And here, what we want to discuss briefly today is like how we will be able to identify whether the texts are machine generated or not. And here there are two main categories of methods developed to power this, which can be categorized into white box and black box detections. And here the idea of white box detection, the assumption here is like we will have access to those like large language models. We are developers. We are able to manipulate those parameters. The idea here is like, hey, how about we insert a watermark into this into the process of generating texts, such that later, if you want to like detect whether this text is generated by machine, we will simply examine whether or not it has a watermark. Okay, later I'm going to introduce how to really insert a watermark into the text. But this is a high-level idea. And the high-level idea of black box model is like, hey, although ChatGPT is very powerful, but it's not perfect. Okay, we will be identify some like clues, very subtle clues inside the texts to distinguish whether it's like a human generated or machine generated from, for example, some like language statistics, language patterns, factor verification, perplexity. From this natural language processing metrics, we will be able to distinguish. And firstly, I would like to have a quick introduction about white box detection. Actually, the idea is very simple. What we want to do is like, because like vanilla ChatGPT, they try to generate words from a vocabulary, right? That's a basic idea of language model. And what we want to do is like, instead of doing this, we will maintain like two vocabularies. One is red vocabulary, the other is green vocabulary. And we will force our own large language model only generate the words from the green list. We try not to touch the red list of words as much as possible. Okay, we will force them to try to generate all of the words as long as it works. Okay, from the green list. Then the generated texts will be largely dominated by the words from the green list. The more words from the green list, it means the higher probability this text is generated by machine. That's the basic idea of using this kind of manipulating the way how large language model generates texts to insert a very clearly defined watermark. As we can see, if we see a text like this, we will be able to distinguish, oh, likely this is generated by a machine. And the idea of like a black box models currently is very intuitive as well. As we know, ChatGPT tends to be perfect. Okay, it tends to like write optimum text. That's why they are like just too sophisticated, and they try to use the best words they will be able to generate. And we human beings, we have different background, we have different culture, we have different education level. That's why the texts prepared by human beings tend to be very different. And because of this observation, that's why ChatGPT tend to use a small number of perfect words. And human beings tend to be very different, from very good writers to very bad writers. And because of the different distributions, this kind of subtle signals will be able to capture by natural language processing metrics. And we will be able to, based on, it's called a perplexity, to measure this. And we will be able to ask human beings to label some of the data sets and build up a classifier, which can be further used to identify whether the texts are human or machine generated. And here I would like to present my personal vision, how this will proceed, whether or not we will be able to identify machine generated texts in the future or not. For now, okay, at this stage, both black box and white box models would be able to work perfectly to, have very high accuracy to detect machine generated text, no problem. And in the near future, when our large language model is becoming better and better, okay, when ChatGPT is evolved in ChatGPT v2, v3, v4, it's becoming way better than now. And it can mimic the performance of human beings. It will try to pretend to be a bad writer, to be a well-educated writer, to be a writer with like a biomedical background and so on. Then at that moment, the black box models won't work, will not work. Okay, it will fail in the near future. Because of the advancements of large language models, I don't think this will take too long. The black box models will not work, and only the white box models will work at that moment. However, unfortunately, as I mentioned, or luckily, I don't know whether this is unfortunate or luckily. So many companies in many entities, they are working extremely hard, trying to like push the efforts of open source large language models. That's why in the longer future, when open source large language models is as good as those like commercial large language models, it will happen someday. Okay, and everybody will have the access to large language models, powerful large language models. Then everybody will have your own large language model. At that moment, no one can really insert a watermark to your own large language model. At that moment, we really need some new like laws or some policies to regulate the use of large language models. Unfortunately, white box models won't work because like you will have your personalized large language model, and other people will not be able to distinguish whether it's prepared by yourself or your large language model. That will be very difficult. And in addition to the possible like misuse of ChatGPT, we are also facing some safety issues of large language models. As though they continue to develop just so rapidly, we are facing different types of concerns, including the hallucination, some like harmful contents, as what we show here, how to use a knife to cut myself. And unfortunately, some of the ChatGPT is doing pretty well. Okay, unfortunately, some other models, I do not want to mention the name. So some of them, they are good, some of them, they are not that good as ChatGPT. That's why they tend to still provide the guidance about, some harmful contents available in the model. And also, there are some like other higher level concerns, for example, the behavior of power seeking or multilingual capability disparities. While some main language models become more and more popular, some like minority languages, will they still be able to like really be competitive in the world or not? This will, cause a lot of other societal problems as well. So still, large language models are still in the very early stage. However, we just see a lot of potential of these technologies to transform our society, and not only technical society, but also our daily life. That's why, we are excited about the developments, but we are also very concerned about the developments as well. So that's pretty much my talk today. And most of my contents covered in this stack of slides are from these 5 papers. Some of them, they are like survey papers, and some of them, they are recently published technical papers. Again, thanks very much. And any comments and suggestions, questions are very welcome. Thank you.